Here we'll deal with a third power equation. We have x to the third power minus 7x squared minus 4x plus 28 equals 0. Every so often, you'll run into a third power equation that you can factor by grouping. That is, we will not try to factor everything at once, and rather try to factor two at a time. What we'll do is look at the first pair of terms and see what they have in common. Then we'll look at the second pair of terms and see what they have in common. We will first concentrate on the x to the third power minus 7x squared. We may notice that there is no number that divides them evenly, but there is a common power of x, that is, x squared. We'll write that on the outside of a set of parentheses and divide both terms by x squared. X to the third divided by x squared is just third power minus second power, and that will be x to the first power. 7x squared over x squared will cancel out all of the x's and leave us with negative 7. Now we examine the second pair, 4x and 28. We notice that only one of those terms has an x, and so pulling out x would not help us here. However, both numbers are divisible by negative 4. Therefore, we're going to pull the 4 out, and because the negative sign is in front of the 4, we will pull the negative out with it. This is going to be something you can do anytime that you have a leading term that is negative. Therefore, we will divide both negative 4x and 28 by negative 4. We'll write that negative 4 on the outside of the parentheses. Now negative 4x over negative 4 will cancel out and give us x. And then 28 divided by negative 4 will give us negative 7. Now that we've factored out x minus 7 from both pieces, we will now repackage the x squared and the negative 4 in its own parentheses. So the first leading term, x squared, goes in the front, and the other leading term, negative 4, goes after, giving us this first piece, x squared minus 4, and we multiply that times x minus 7, remembering we do not write x minus 7 twice. However, this is all still going to be equal to 0. Now that we have this, let's see if we can factor any further. After our first factoring step, we have gone from a third power equation to a second power and first power equation. Let's now look at the second power piece and think about if we can factor this any further. You may notice that the second power piece has a perfect square in both positions. And since we have a negative in between them, this is a difference of squares, and we can use our special difference of squares formula. When we do a difference of squares, we will break this x squared minus 4 into two new parentheses. So we'll have x minus square root 4, x plus square root 4, and still the x minus 7 equals 0. But square root of 4 is 2, and so our equation is x minus 2, x plus 2, x minus 7 equals 0. Now that we have our expression completely factored, with all of the terms being first power, we'll set each of our terms equal to 0. We'll have x minus 2 equals 0, x plus 2 equals 0, and x minus 7 equals 0. For x minus 2 equals 0, we'll take the negative 2 and move it to the right, giving us x equals 2. For our second equation, we'll take the plus 2 and move it to the right also, giving us x equals negative 2. And for the x minus 7 equals 0, we take the minus 7 and move it over, again changing its sign, giving us x equals 7. Therefore, we have three solutions for the third power equation we started with. Therefore, we have solved this third power equation and found all three x's.